Let's dive into an example to see how Flowmon investigation works. In the traffic chart of the Flowmon Monitoring Center is visible a noticeable peak that requires further analysis. To analyze which transport protocol contributed the most to the peak, the interval can be selected and the attribute for statistics calculation can be changed and sorted to IP protocol and flows. After clicking on the Process button, the results indicate that nearly all flows use the TCP protocol. At this stage, the investigation feature presents a key differentiation from traditional analysis methods. Without the investigation feature, continuing with the analysis would require specifying the filter and potentially modifying the statistical calculations. This approach could result in the loss of current results and make revisiting and reanalyzing data more challenging. To initiate the investigation process, click the Start Investigation button. The panel with investigation appears on the right side. You can see name of the investigation at the top. When the investigation is not saved yet, it doesn't have a name, and the default title investigation is displayed. Buttons on the top bar allow you to save, load, recompute, or export the investigation. You can also manage steps or view. Below the buttons you can see data sources such as used interval, profile, and channels. The bottom part of the panel shows the visual representation of the whole investigation. At the beginning there is only one step that represents one data analysis within the investigation. By adding more steps to the investigation, this visualization will start to look like an inverted tree with a root at the top and leaves at the bottom. Let's return to our example. The next step in the investigation involves identifying which application, such as transport port, has been utilized within TCP communication. This can be achieved by accessing the results of the analysis in the main panel on the left side, right-clicking on the TCP protocol, and selecting the Copy to a Filter window option. Now we can modify how statistics are calculated by changing the parameter from IP protocol to port. Instead of using the Process button, select the Process as Child Step button. Once executed, Flowmon calculates the query and displays the data in the main panel. In addition to the new analysis results, a new step appears in the panel on the right side. The visualization now shows two steps, the root step at the top labeled as Untitled Step and the second step labeled Protocol TCP. The first step contains the empty symbol, representing the absence of filtering in this step. In contrast, the second step includes a blue box that displays the filter being applied within that step. This signifies that the results contain only data matching the specified filter, the TCP protocol. A line between the two steps that indicates their dependency. From an analytical perspective, this signifies that the initial step involves analyzing the data to produce results. These results are then passed on to the subsequent step, where they are reanalyzed using different settings, such as filters and statistical aggregation parameters. The chart in the analysis results indicates that nearly all communication is directed to the HTTP port. The next step involves identifying which IP addresses are using this port. This can be achieved by right-clicking on the port value, copying it to a filter window, and selecting the Process as Child Step button. The latest and lowest step in the tree now represents that the step is working with data derived from the previous steps. As a result, the step operates exclusively with data containing the TCP protocol, further filtered by the HTTP port. To enhance clarity within the tree structure, steps can be renamed by selecting the three dots icon in the step and choosing the Rename option. And the step will be renamed to Web Traffic. Similarly, the first step in the tree will be renamed to Top Protocols by Flows. To demonstrate the value of the investigation feature, Another port within the TCP traffic can be analyzed without losing the results for the HTTP port. This can be achieved by returning to the previous step in the tree, labeled as Protocol TCP, by selecting the corresponding node. Based on the results table, the second row, port 443, HTTPS, can be chosen for further analysis. The value can then be added to the filter, and the process continued as a child step. Disregarding the results, the investigation tree is revisited. The structure now more closely resembles a tree, with a new step for port 443 added under the protocol TCP step. This indicates that the step is processing only TCP traffic, similarly to the web traffic step. Navigation between different steps of the investigation can be performed freely to view results from various moments within the process. Additional steps can be incorporated into the investigation process as necessary. For instance, when there is a need to analyze the UDP protocol, the corresponding step can be added by selecting the plus button at the desired point in the investigation structure. This has created an empty step without any filter, which is indicated again by the empty symbol. The statistics parameters will be changed to port instead of IP conversation, and the filter specified as protocol UDP before clicking on the process button. The analysis can proceed as it would with the TCP protocol. You can use also your own variables for investigation. Variables provide dynamic, centralized control over filters. Assign variables to filters and adjust them in one place to automatically recalculate results across all dependent steps. Add new variable using the button and set its parameters. Additionally, reference variables enable the powerful chaining of queries by extracting specific values, such as the top IP address from one step, and applying them as filters in subsequent queries. This makes multi-step analysis more flexible and responsive to evolving data insights. The variable is now ready to be used in the filter. At the end of the investigation, the results can be saved for easy access in the future, to serve as a template for similar scenarios, or to share with other users. This can be done by clicking on the Save button located at the top of the right panel in the investigation tree. When saving an investigation, you can specify the name, add a description, and select the option to share the investigation with others. When the investigation is saved, all future changes made within it will be automatically saved under the same investigation, as indicated by the message. All changes were auto-saved. For scenarios involving experimentation, such as trying different filters or modifying the investigation tree without altering the original investigation, it is recommended to first use the Save As button and assign a new name to the investigation. This ensures that the original investigation remains unchanged while work continues on a duplicate version. One of the functionalities worth highlighting is the ability to load a previously saved investigation. To do this, the investigation panel provides a load button, allowing users to specify filters to efficiently locate the desired investigation. Finally, let's look at the functionality of the Process All button and the concept of investigation inconsistency that are worth explaining. Steps involve processing data that has been produced as the output of previous steps. Inconsistencies can emerge when changes are made to a step result upon which another step relies. This can be demonstrated by returning to the first root step to modify the selected interval or by adjusting the filter and clicking the Process button. The system has identified that the user has made a change that will make the following steps outdated. User has two options. Ignore the request and continue with the changes. That means that the current step will contain updated data, while other steps will retain results derived before these modifications. Or you can recompute now. This option initiates the recalculation of all steps, ensuring that all steps contain data based on the current filters. The step with inconsistent data is marked with an orange color. Steps can be executed individually by clicking on the Process button, which is particularly useful when multiple changes are being made, and recalculating all steps repeatedly is unnecessary. Alternatively, the Process All button can be used to automatically recalculate all steps sequentially. Now is the investigation updated and ready to further use.